Back in 2008, this paper just appeared online from a totally mysterious author named Satoshi Nakamoto, and it laid out something that was frankly completely radical. A way to send money over the internet, person to person, with absolutely no bank in the middle. So let's dive into this incredible 9-page document and really unpack how it all works.
All right, here's our game plan. We're going to start with the problem that Nakamoto saw with our whole system of digital trust. Then, we'll tackle the biggest hurdle of all, something called double spending. After that, we'll see the genius solution, this chain of proof, and how the network actually puts it to work. And finally, we'll get to the really clever part, why on earth anyone would help keep this system honest in the first place.
So, let's set the stage. What was the big problem that needed fixing? Well, think about it. Every time you buy something online, you're not really just paying the seller, are you? No, you're relying on this whole army of middlemen, your bank, their bank, the credit card company, to handle the transaction. And this slide really puts the two models side by side. On the left, you've got the old way. A bank in the middle means higher costs, because they have to mediate disputes. Now, the fact that transactions are reversible might sound like a good thing for you, but for merchants, it's a constant headache of dealing with fraud. But on the right, that's the new vision. Direct payments, no middleman costs, and transactions that are basically impossible to reverse. And this quote from the paper just nails the mission statement. The goal is to swap out this fragile idea of trust with the cold, hard certainty of math, of cryptographic proof. But if you're going to do that, you have to solve one massive fundamental problem. And that brings us right to the heart of it all. The central challenge for any kind of digital money, what we call the double spending problem. Just think about it for a second. If I have a digital photo or an MP3 file, I can just copy-paste it 1,000 times, right? So how do you create a digital dollar that can't just be copied and spent over and over and over again, especially if there's no central bank keeping an eye on everything? Exactly. Unlike a physical dollar bill that can only be in one wallet at a time, a digital coin is just, well, it's just data. The person receiving it has no easy way to know for sure if the person paying them didn't already send that exact same digital coin to somebody else a second ago. So what's the fix? Well, this is the paper's big aha moment. To stop someone from spending the same money twice, everyone needs to see everything. The solution is a shared public history, a giant, open ledger that everyone has a copy of. If we all have the same history book, we can all agree on which payment came first. Okay, so we need a public history that everyone can trust. But how in the world do you build that without a central authority? Well, the paper lays out this brilliant solution based on 3 key components that together create what it calls a chain of proof. First up, the very definition of a coin is changed. It's not a file, it's a chain of digital signatures. When you want to send a coin, you essentially sign over the ownership to the next person using your private key. This creates a verifiable trail of who owned what and when. But that alone doesn't stop double spending. The next piece of the puzzle is what the paper calls a timestamp server. So the network bundles up a bunch of recent transactions into a block. It then creates a unique digital fingerprint, a hash, for that block. And here's the key. That new hash also includes the hash of the previous block. This creates a chain, where each new link is cryptographically welded to the one before it, making it super secure. But wait a minute, what's to stop me from just creating my own longer, fake chain and fooling everyone? That's where the third and most crucial ingredient comes in, proof of work. To add a new block to the chain, you have to solve an incredibly difficult computational puzzle. It takes real-world resources, your computer's processing power, and electricity. It's hard to do, but it's super easy for everyone else to check that you did it correctly.
And I love this analogy from the paper. It's not one person, one vote, it's one CPU, one vote. The true history, the correct version of events, is always the longest chain. Why? Because that's the one that has the most computational work, the most votes invested in it.
So, we have all the core ingredients: digital signatures, a time-stamped chain, and proof of work. Now, let's see how the network actually puts this all together in a step-by-step process. It's actually a pretty elegant dance. Step 1, you broadcast your transaction to everyone. Step 2, all the nodes or computers on the network collect these new transactions into a block. Then, step 3, they all start racing to solve that proof of work puzzle for their block. When one of them finds the solution, they broadcast it out. Everyone else checks it, and if all the transactions are valid, they accept it. And here's the kicker. They show their acceptance by immediately starting to work on the next block, chaining it to the one they just received.
And this one simple rule is the secret to how this massive, decentralized network stays in sync. There's no boss, no central coordinator. The nodes just vote with their processing power by always building on top of the longest chain they see. It's that simple.
Okay, but this all sounds like, well, a lot of work, a lot of electricity, a lot of computing power. So you have to ask the most important question. Why would anyone bother doing this? What's in it for them to play by the rules?
And the answer is just brilliant. It's built right into the system itself. The first node to solve that proof-of-work puzzle and create a new block gets a reward, a brand new, freshly minted coin. This is actually how new bitcoins are created. The paper compares it to gold miners spending resources to pull gold out of the ground. Plus, you can also collect small transaction fees from all the payments included in your block.
And this gets us to the really beautiful game theory at the heart of Bitcoin. It basically says that for a greedy attacker, it's just more profitable to be honest. Think about it. If you have enough computing power to attack the network, you'd make way more money by just using that power to create new blocks and earn the rewards, instead of trying to cheat and undermine the very system that makes your own wealth valuable.
And the security here isn't based on hope, it's pure math. The paper actually runs the numbers. Let's say an attacker has 10% of the entire network's power. If they try to reverse a transaction that's just one block deep, they've got about a 20% chance. Not great, but possible. But just watch what happens as the honest network keeps adding more blocks on top.
After just 5 more blocks are added to the chain, the attacker's chance of success plummets to less than 0.1%. It becomes statistically impossible very, very quickly. With every new block, the history becomes exponentially harder to change. It's like pouring digital concrete over the past.
So let's just zoom out and put a bow on this. What we have here is a system for electronic payments that doesn't need trust. It's a peer-to-peer network secured by proof of work, creating a public history that is, for all practical purposes, unchangeable. Its real power comes from its unstructured simplicity, where every node votes with its CPU power to enforce the rules, all without any central authority whatsoever.
You see, this paper didn't just invent a new form of money. It introduced a whole new way for people to agree on things without a middleman. It replaced institutional trust with mathematical proof. And that leaves us with a really fascinating question to think about. If you can do this for money, what other parts of our digital lives, from voting systems to supply chains to our very identities, could be completely rebuilt on this incredibly powerful foundation?